Welcome back, guys. We're still looking at the derivative and getting a little bit better understanding of how this can really help us. So what we have here is we have a graph. So based on the slope of the tangent, we can tell if it's increasing, decreasing, if there's a maximum or minimum even. So the derivative can actually be really helpful for us to know what the original function looks like. So let's just take a look here. So let's look when x is -6, we're going to find the slope of the tangent line. So this is a little bit challenging because you try to have just straight, perfect lines that are tangent to all of that really well there. So if I were to pick 2 points, so I'm going to use this point, obviously, and probably this point right here, then it looks like the slope of that tangent line. So I'm just making this just kind of trying to make it as straight as possible. Using a ruler helps to see what that tangent line looks like. So the estimation of that derivative, the slope is going to be -3 over -2, which actually ends up being a positive 3 over 2. So what you'll notice is that my original function, which is f of x graphed here, is increasing when x is -6. So this is going to be increasing. And then if we're going to find the slope of the tangent line, we're going to have y minus 0 is equal to the slope, which is 3/2, times x plus 6. So that would be the slope of the tangent line. So it's approximation because our tangent line might not be exactly perfect, but it's increasing. My slope is positive. Those are the key things you want to keep in your mind. So we have the slope of the tangent line at x equals -4, excuse me. So at x equals -4, what you'll see, nice horizontal line. So the slope there is going to be, if you'll remember, 0. This is a relative max. And then the equation of that line is just going to be y equals 2. So straight horizontal line shows a max. And then if we're going to look at y equals +3, and we're going to have the slope there. So I think this is it. I'm going to use this point and this point here. That's the best I feel like I can do. Then the slope is going to be -3 over -1. Which is a +3. It's still increasing at this point. The slope of the tangent line, the equation of the tangent line is going to be y, plus 1 is equal to our slope, which is 3, times x minus 3. All right, so it's just using point slope form there and just leaving it. You don't have to simplify, distribute, all that good stuff. So what you'll notice is that a couple of things. So if f prime of x is greater than 0, then f of x is going to be increasing. All right. So if our slope is positive, which makes sense, if our slope is going up, then our equation is going to be increasing, or our function is going to be increasing, I should say. So, but then also, likewise, which we didn't see this in our table, but if f prime of x is less than 0, so if it were to be negative, then f of x would be decreasing. All right, so at that specific point. So let's make sure we note that. And let's change these to a. So if f of a, so these are at specific x values. Sorry about that. So now we'll talk about the function as a whole. So if f of x has a slope of 0, it can be a maximum or a minimum. Okay, so we can look at that as well. So f of x has a relative max if the derivative at A is equal to 0 and f prime of x, so the function value changes from from positive to negative. So if it goes from positive to negative, if the derivative does, then you would have a relative max. And so remember, derivative, slope of the tangent line, if it goes from positive to negative, then you have a relative max. And then lastly, is kind of the opposite of that. So f of x has a relative minimum. Again, if the derivative at A is 0, so if the slope of the tangent line is 0, so it's a horizontal line, then that's going to be either a relative max or a relative min. And that's going to happen if f prime of x changes from negative to positive. So if it goes from negative to positive, it's going to be a minimum. If it goes from positive to negative, it's going to be a maximum. That's f prime of x. So numerically, the value of derivative at a point can be estimated by finding the slope of the secant line passing through 2 points. So remember, that's how we derive to the tangent line, is that our secant line, our h got so small that our secant line became a tangent line. So we can see a table of values of f of x and be able to find roughly the equation of the tangent line. So if we're going to find it at x equals 1, then what you'll use, so this is my point here, I'm going to use 0 and 4. I'm going to use these values here and here. So I'm going to find the slope first. Remember, derivative is a slope of the tangent line. So to find the slope, that's going to be the change in y over the change in x. So the change in y is going to be 0 minus 1, and the change in x is going to be 4 minus 0. So it's a negative 1/4. So since my slope is a negative, that means that it's going to be decreasing. Okay, so that to me makes a lot of sense. So the equation of the line that is at this value of x, so the point of tangency is going to be our 1, negative 3. So then the slope of the tangency is going to be approximately negative 1/4. We don't know for sure, but we're just kind of guessing there because we're using the secant line. So it's roughly, it's probably pretty close to that. So therefore, we're going to have y plus 3 is equal to negative 1/4 x minus 1. So using point slope form again. The estimation of the derivative, remember, that's a slope of the tangent line. So that's going to be the change in y over the change in x, and we're finding at x equals to 6. So I'm looking at this point, I'm going to use the point to the right and to the left so that we're finding the secant line. So this time I'm going to look at this value, or these values here, these 2 points, to find the slope. So I'm going to have 2 minus 0 over 10 minus 4. So that's going to be 2 over 6, which is a positive 1/3. And since our slope is positive, that means that our function is going to be increasing. Our point of tangency is at 6, negative 7. And then our slope of tangency, which we found, remember, is going to be approximately a positive 1/3. So the equation of that is going to be y plus 7 is equal to 1/3 times x minus 6. So that would be the equation of the tangent line at x equals to 6, or basically the derivative of this function of the table at x equals 6. All right, so let's take a look here at this graph that's g of x. It's graphed there. And we're going to note where we notice that g of x, where the where the derivative is going to be less than 0. So that's going to be our decreasing value. So where is the graph decreasing? Well, our graph is going to be decreasing here and here. So that means that our derivative is going to be less than 0 for values. So g prime of x is going to be less than 0 for any, over any, let's say 4, let's say on, let's see, this goes from -4 to -2, unioned with 1 to infinity, okay, because the graph is decreasing. The graph is decreasing for those values. So then g prime of x, so the derivative of x of g is going to be greater than 0. That's going to be on our increasing pieces here. It's going to be from -infinity all the way up to -4, and then -2 up to, -2 to 1 there. So because g of x is increasing there. And then our values of x, where g of x is going to be, or the derivative of our function g is going to be equal to 0. It's going to be equal to 0. Ooh, that's not a very good one. Let's see. Here. Oof. So here, here, and here at those x values. So the derivative of x of g is equal to 0 for x equals -4, -2, and 1. So it either has a relative max or min at those points. So we know that the slope of the tangent line is going to be 0 at those 3 x values. All right, so this is the graph of -1/2 x plus 1 squared plus 4. We're going to draw the tangent line at x equals 1, and then we're going to estimate the value of the derivative of f. So the slope of the tangent line I think is going to be here. And then I estimated this to be negative. I'm going to use this point here and this point here to find the derivative. So f prime of 1 equals -2. So we know that it's decreasing because the slope of the tangent line is negative. We're going to find the equation of the tangent line at equals of f of x at x equals to 1. So remember, the point of tangency is going to be at 1, 2. And then the slope of tangency is going to be roughly -2. Again, we kind of just estimated there. And then, so then plugging that into point slope form, I'm going to have y minus 2 is equal to -2 times x minus 1. So now we're going to look at the normal line. Now, this is not a big thing because you'll see it a little bit, but it's not nearly as big as the tangent line. So the normal line is perpendicular to this line at the point of tangency. So we're going to draw the normal line. Now, what's really nice about this is that I actually probably can estimate the slope pretty well here because I know that perpendicular lines have opposite reciprocal slopes. So, and then we're going to write the equation for the normal line. So I know that the slope of the normal line is going to be the opposite reciprocal. It's going to be a positive 1/2. And then I also know that's going to pass through the point 1, 2. So I can write this as y minus 2 is equal to a positive 1/2 times x minus 1. And so that's the equation of the normal line. So normal line is perpendicular to the tangent line at any value of x. All right, so we just kind of took a little bit deeper dive into derivatives and what that's going to look like and what does it mean for our graph. So if you see the graph of f prime of x, you have a pretty, you can have a pretty good idea of what f of x looks. We're going to dive into that in a little bit in a few lessons, but this is just a good idea of how is the derivative and what is a derivative and how does it help you know things about your original function. So this is just kind of understanding the derivative a little bit better. Remember, when I say slope of the tangent line, you say derivative. When you say slope of the tangent line, I say derivative. So remember that.